Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to be taking a look at transversals, a common tool or common concept you found associated with geometry. So let's go ahead and get started. So this picture here, I guess in your upper left hand corner, is an example of a transversal. And so transversals are commonly used in geometry. And so basically, to make this as simple as possible, a transversal is a straight line that intersects two or more lines that are in parallel. So in this example right here, line L and line M are parallel to each other. That is a given in this particular situation. And line R intersects or crosses these two lines at an angle. And so when this happens, there's lots of interesting things that you can talk about and discuss to understand different angles and types, etc. And this is a very commonly used tool. So these numbers here represent the different angles that are in this particular transversal. And I forgot to mention that this is also a plane here. So we got angle 1, 2, 3, 4, 5, 6, and 7, 8. Now, the first thing we're going to talk about in connection with this is the idea of interior angles. So we're going to deal with that first. So interior angles. And so when we're talking about interior angles, we're talking about angles that are inside the parallel line. So in our example right here, angle 3, angle 4, angle 5, and angle 6 are all interior angles. They're inside the line L and M. They're inside here, inside the little space here, inside the middle. These are interior, they're inside. Now, we also have exterior angles. I don't think it's too hard to figure out what that is now. When we're talking about exterior angles, we're talking about the angles that are outside of the parallel lines. So in our example here off to the left, that'll be angles 1, angles 2, angles 7, and angles 8. Again, this is not that deep, not that complicated in many ways at all. Now, the next thing we're going to talk about is corresponding angles. These are angles that have the same relative position within a transversal, excuse me. So, for example, if you look at angle 3 over here in our example, angle 3, I'll highlight him for a second. Angle 3 and angle 7 are in the same relative position. They're both on the below their line here to the left. That's what's happening. So angle 3 is below level line L and to the left of angle R, or the line R, excuse me. And you also see angle 7 is below angle M and is also to the left of line R. So they're in the same relative position. So corresponding. So the corresponding angle, and of course there's more than one example. Corresponding angle. So in this example, it would be angle 3 and also angle 7. Angle 7 are corresponding angles in this particular example. Now, an interesting new caveat for this, and we're going to go to the next slide for this one, is when you know the measure of the angle, you can use your knowledge of this information we're talking about here to come up with some interesting things. So I'm just going to erase these angles here so that I can write over them. And so I'm going to share with you something that is kind of interesting. So let's just say here that the measure that used to be angle 1 was 100. And so that means, using our knowledge of supplementary angles, that measure 2 is going to be 80. Now here's the thing. When you know that two things are corresponding angles, they have the same relative position, that also means that they're going to have the same measure of their angle. So again, wrapping this up, angle 1 is corresponding with angle 5. This means that if the measure of angle 1 equals 100, that means the measure of angle 5 is going to equal 100 as well. And that is the advantage of using your knowledge of corresponding angles. And again, I want to do angle 3 and angle 7, but I haven't quite explained things so that we can have success with that. And so to move on here, if measure of angle 2 equals 80 degrees, that means the measure of angle 6, which is the same corresponding angle, is going to be 80 degrees as well. So let me put the little degree sign. This is how everything is kind of working together. Our prior knowledge is helping us with what we're doing right now. So if you're familiar with supplementary angles, it helps you to understand these things that we're talking about right now. So when we're talking now about something else here, we're going to look at alternate interior angles. These are, on opposite sides of each other. So in this example here, alternate ulterior angles, alternate. That would be, for example, angle 3 and angle 6. They're alternate interior. So they're inside and they're kind of opposite of each other. They're alternating. They're on opposite sides of our line R here. Opposite side of the transversal is what I meant to say, excuse me. And then for exterior angles, let me give you another color here. Exterior angles, exterior angles, an example of that would be angle 1 and angle 8. So they're on the outside, again on the outside of the parallel lines, and they're on opposite sides of each other. So this is how it works. And so we can use this information to solve lots and lots of information. One thing I forgot to mention, if I go back to my one right here, is that when you have this measure of measure 1, this is when I was talking about corresponding angles. We know that when you have a line here that on opposite sides of a line that cuts across is going to be 180 degrees. So we know that the angle 1 is 100, angle 2 is 80 degrees, and now we have to use our knowledge of vertical angles and also adjacent angles to figure things out here for the other sides. So if angle 2 is 80, that means that angle, I think this was 3, I believe, angle 3 is going to be 80, and then this guy over here, angle 4, is going to be 100 because they're opposite of each other. And of course, when they're next to each other like that, they also add up to 180. So I wanted to mention that as well. So let me conclude what we talked about and finish this video. So in this video, we were introduced to the ideal of transversals. And essentially a transversal is where you have two parallel lines that are intersected by another line at a particular angle, whatever that angle might be. And so when you have this kind of a situation, of course it's in a plane, there's lots of information you can find out about, this transversal. You can talk about interior angles, angles inside the parallel lines, exterior angles, angles outside of the parallel lines. You can also talk about corresponding angles, angles that are in the same relative position. And then of course, after you deal with that, if you know the measures of certain angles, you can figure out all the other lengths of all the other angles in the particular thing using your knowledge of supplementary angles and also complementary angles and things of that nature. And so on this particular screen, we knew that angle 1 was 100 degrees. That means using your knowledge of supplementary angles that angle 2 had to be 80 degrees. And then using your knowledge of adjacent angles, that means if angle 2 is 80 degrees, that means angle 3 must also be 80 degrees. And then of course, then using your knowledge of that, and by the way, this is angle 3 right here. I know I kind of erased it, and this is angle 4 right here. Using your knowledge of that, you can also figure that angle 4 was 100 degrees. Lots of connections here when we're dealing with transversals. And the last thing that we talked about, the last two things, was alternate angles and exterior angles. So alternate interior angles, that'd be like, for example, angle 3 and 6. They're both inside, but they're on opposite sides of the line there, or the transversal, if you will. And exterior angles, they're outside the parallel lines, and they're also on opposite sides of the line. For example, angle 1 and angle 8. So, my name is Darren Thomas. I am the Director of Educational Research Techniques. Thank you for watching, and take care.